permissions to our admin profile. If we'll use the show full config, we will see the full configuration, either setting up trusted host or even setting up a two-factor authentication by using an email account. That is possible only on the command line. Alright, so we have our admin account. So now let's move over to network interfaces. And this is the topology that we need to configure. This is a very basic SMB topology. You have your LAN, which is connected to one interface on your FortiGate, and you have your DMZ, where your server sits, which is connected to another interface, and you have your ISP router, which is connected to your WAN interface on your FortiGate, which is this WAN interface. So let's start by configuring the LAN interface and the DMZ interface. So choose your interface of choice, edit. Now name your interface. I will name it LAN, and choose its role. Different roles means different settings, but our role currently is LAN. We will configure the IP address of the gateway itself, that is 10.0.4.1/24. Another thing that we need to configure is the administrative access. We will use HTTPS to connect to that interface. We will also allow ping, and we need a service, a DHCP service that will run on our interface, so that hosts that will connect to our interface can ask for IP addresses, and we will apply that using the pool, which currently is up to 254. We will set it to only 50 IP addresses. You can head over to the more advanced DHCP server and assign scopes, assign specific IPs to match your host's MAC address, but we will not do so. Device detection allows your FortiGate to actually detect the type of devices that runs on your network. That is either an Android, a Windows PC, a Mac computer, and so on. It does so by looking at its MAC address, user agent, TCP fingerprint, and other methods. You can also enable captive portal on your interface. We will not do so. So that's it for our LAN interface. And now let's configure our DMZ interface. So let's edit it, name it DMZ. Now the role will be DMZ, and once you do so, you will see that you don't have a DHCP server on that interface, since as a best practice, do not allow DHCP service on your DMZ. So let's configure its IP address, 10.0.5.1/24. We will only use HTTPS as our administrative access, and that's it. Now we have two interfaces. One is dedicated to our LAN, and the other one is dedicated to our DMZ, our WAN interface. Let's just edit and name it WAN, so it will be easier when we configure our policy later on. Alright, so now we have our interfaces set up, and the next thing to do is to manually configure a route entry that will allow all packets to flow towards the gateway interface, that is our WAN interface, and from there to the internet. So we'll move to network, static route. Let's configure a new default route. Our gateway interface sits on the WAN interface, and its IP address is the 10.0.3.1. We can determine the priority of our static route and its distance using the following configuration, but we will not get into it. You can see I have dozens of videos that are dedicated to the different routing attributes of your FortiGate. Okay. So now we have one static route which actually tells different packets that if you wish to go to just about any destination that doesn't have its own routing entry in the routing table, move to the gateway at the 10.0.3.1. using the WAN interface. And now let's move and see our new entry, our new route entry that we have just configured. We will do so using the command line, although you can do so also using the graphical user interface. So get router info, routing table all. And there you see you have a new static route that actually points to the default route via the 10.0.3.1 IP address. All right, so we have our interfaces, we have a static route, and the next thing to do is actually to create the policy itself, that policy that will allow packets to flow from interface to interface by matching the traffic and seeing if it is denied or allowed. So to create a policy, we will move over to Policy and Objects, IPv4 policy, and create new. The first policy that we wish to create is a policy that will allow everyone in our LAN to get out to the internet using any service at any time. So let's just name our policy full access. The incoming interface is our LAN interface. The outgoing interface is our WAN interface. The source, we will not limit users, so we will just allow anyone to get out. Of course, if you need more granular control over your policy, you will create firewall address objects and you will define which one can get out and which one cannot. You can also create user groups and users. Destination, all. We are not limiting the traffic to a specific place. Anyone can get out to anywhere. Scheduling, always. Service, again, we can limit it to specific protocols, but we will keep it to all. Now, the action is accept. The other thing to note is the inspection mode, which we will look at when we create security profiles. We want our traffic to be natted. That is, our traffic currently happens on our private IP addresses, but when we go out to the public internet, we need to translate our IP addresses to the public front interface of our FortiGate. So that's what we will do. And we can configure the different security profiles. We will do it very soon. Now, in terms of logging, we don't want only security events to be logged. We want all sessions to be logged. So we will enable all sessions. Okay. So now we have our first policy, which is the full access policy. All right, so now let's create our second policy for the DMZ. And from the DMZ point of view, let's just allow traffic that comes from the internet towards the DMZ. For our purpose, let's just make it from anyone, but in your environment, just configure it based on your needs, security policy, events, and so on. Destination, all. We can, of course, configure a specific, you know what, let's just configure an address for our server. Let's assume that we have a web server that anyone can access using HTTP and HTTPS. So let's name it web server. We will use the 10.0.5.4/32. So we will so it will point out exclusively to that web server. Now the service can only be HTTP and HTTPS. We will use the different security profiles and we will log all sessions. Okay, so we have a second policy that is towards our DMZ, but now the traffic comes from outside towards a specific web server, and we have only allowed the HTTP and HTTP service. Now, once you finish up with your different policies, you will need to apply the different security profiles. For that, you will move over to security profiles, choose the one that suits your security needs. You will probably choose antivirus, web filter, maybe application control if you want to control applications that your users are using. And once you create a security profile and name it, you can enable it in your policy by going to the policy page and select which profile is needed. Alright, now the last thing to do is to move to your system settings and choose the appropriate settings that will make you feel good while you administrate your FortiGate. Either in terms of how much time do you want your idle timeout to be, how do you want to customize the look and feel of your FortiGate, and do you want to use any other email service other than the FortiGuard email service. So you can do all that. Now, we have actually looked at the basics of putting up your FortiGate in a typical scenario. If you want to learn more, please subscribe to my channel. I regularly upload 2 to 3 videos every week. In today's video, we will look at how to list processes, in your FortiGate using the Diag Sniffer coming up. A process that consumes too much CPU or too much memory, as the IPS process, can cause your FortiGate to have bad performance. So how do you tackle it, and how do you see the processes that are running on your machine? To do so, you'll go to the CLI, Diag Sniffer. Now, following that basic command, which will display the processes, we can filter it using other parameters. So if we'll use 3, we'll have a refresh time of 3 seconds. Now if we'll use the 10 after it, we'll have 10 lines that are displayed. Now the last thing is the iteration. So let's use 3 for that, and let's see what we have. So we have 10 processes, again another 10 processes, and another 10 processes. Now let's look at the processes themselves and understand what do we see here. We actually see the process name, the process ID, the process state, either in sleep or running or maybe a zombie process. We also see the amount of CPU that your process is consuming, that is the row before the last row, and the amount of memory that it consumes. Your FortiGate CLI is probably your best friend when you're administrating your FortiGate. So, a new series dedicated to CLI tips. Let's start. The first CLI that we will look into today is the get system status. Now, it isn't a fancy command. It doesn't sniff any packets. It doesn't show the different sessions that are running on your FortiGate. It just shows you the information. What is your FortiGate up to? So what can we see? We can see the FortiGate version, we can see the build number, we can see the different security profiles, database dates. We can also see the serial number of your FortiGate. We can see if your FortiGate is working in a NAT mode, that is Network Address Translation Layer 3 operating mode, or maybe it is working in a transparent mode, which is a layer 2 mode. If you are using VDOMs, it will show you. If you are in an HA mode that is working in a cluster, either in a passive mode or in an active mode, it will also show you. Currently, as we can see, we are not participating in an HA cluster, so the HA mode is standalone. We can also see if we're using a hard disk or maybe we're using a flash disk. So the get system status will show you the most relevant information regarding your FortiGate. Another chapter in 2 minutes CLI, and in this part we will look at the execute log display. How can we show up the different logs categories in the command line? Coming up. Logs are critical to your network stability and your network security. Now, it's a good practice to keep logs for at least a week. You can look at the logs either through your FortiGate or through a FortiAnalyzer or even a syslog server. Now, in your logs, you have different categories, and we will look at them through the command line. So for that, we'll use the execute log filter category. Now, if you're not familiar with the different categories, just press enter, and there you will see the different categories. So let's just use category 1 for event logs. Now, after doing so, you will need to write down execute log display. And there we have it. Now, it shows up only the 10 last log events. If you want to watch the other 10, just press again and you will see the other 10 log events. FortiGate also shows you that you have 237 logs that are found and only 10 logs are returned. 6.4 is one of the latest releases of Fortinet, and they're doing a great job from release to release, adding new features. And up until now, there were dozens of videos all over describing the new features of 6.4. Well, I've decided to create one that will focus on the more friendly features of 6.4. So let's start. The first friendly feature, is the execute speed test that you can do on your WAN interface. To do so, you'll have to have the SD-WAN network monitor license. Once you have one, you can jump up to your WAN interface and execute a speed test. Now, when you do so, the results will be added to your estimated bandwidth, the estimated WAN bandwidth, but you will have to be connected to FortiGuard and to, I believe, Google's or AWS speed test servers. The second friendly feature is a fantastic one. I've been always asked when dealing with security profiles, which feature is supported either in flow-based inspection mode or in proxy-based inspection mode. And it seems that up until 6.4, you had to remember which feature is supported and where. So from now, you can actually create a new security profile. And if you wish to see which feature or which capability is supported under the proxy inspection mode, the only thing that you need to do is to click on the proxy based, and there you will see that you can only use content disarm and reconstruction under the proxy based mode. The same goes to web filter. Just click on the proxy based and you will see the features that are supported only on a proxy-based inspection mode. The next friendly feature is actually not a feature. It is a way of describing things much more clearly. So when you go to a network SD-WAN and you add up new interfaces to be part of the SD-WAN interface, and the next thing is to create an SLA, a performance SLA, where you configure the SLA server and the SLA target. The next thing is to go to SD-WAN rules. Now, in SD-WAN rules, at the end, you actually create your SD-WAN strategy. The SD-WAN strategy can be manual, best quality, maximize bandwidth, and lowest cost. I can tell you that every student uh, asks me, what does it mean? What is best quality? What is maximized bandwidth? So finally, FortiGate actually describes each strategy and what it does. The next friendly feature is a cool feature, which is the IP address tooltip. Whenever you hover with your mouse over an IP address, it will show up more information on that IP address. So let's go to login report and application control, and let's see what happens when we hover towards that IP address. Well, we can see that the owner is Google. We can see the location, which is England. We can also see the latitude, longitude, and the running services. Let's go to another IP address, and that IP address also is owned by Google. Let's find an IP address which may not be owned by Google. All right, so we have an IP address that the owner is Amazon, and it seems as the local CDN here in Israel, Tel Aviv. Another friendly feature is the Add widget, which is now much more organized than it was before. You have dozens of widgets. Some of them are new. I believe that the IPsec and the SSL VPN widgets are new. And you have a bunch of Wi-Fi widgets that shows you the channel utilization of the access point, clients per access point, interfering access points, and so on. And the last friendly feature is the fact that you now don't have an IPv4 policy and an IPv6 policy. You only have a firewall policy. You can add up an IPv6 or an IPv4 address object to be added to the source and destination fields in your one policy. You're a small business, very small. 6 employees, 6 computers, 1 switch, 1 access point, an ISP router, 1 subnet, and a network attached storage that serves as a file server. That's right, no domain controller servers, no clustering, everything is flat and simple. But you still want to protect your network assets. You still want to be able to connect to your file servers from remote, give permissions to the management to specific domains, and you decided to buy a firewall, a small firewall, not too fancy. So here are the 7 things you must do in order to start and work with your firewall. All right, so the following are the basic steps that you as a small business will need to do once you get your FortiGate or any other firewall in your business. Now, the very first thing, remember, once you configure your firewall, you're the administrator of that firewall. You're the super admin. So you will need to hardening your admin account. You can use two-factor authentication. You can also use an email-based mean to get a token in your email. I have done a video on that before, and you can just click the link above and go straight to it. Another thing is trusted host. You will need to configure either 1, 2, or 3 IP addresses that the admin can actually connect from to the management interface of your FortiGate. So configure your office address, configure your home address. Don't let anyone get into your FortiGate from outside. The second thing that you can do is to segment your network. Now, even if you have only 6 or 10 employees, and 3 of them are in the marketing department, and 4 of them are doing sales, create a new interface. You have lots of switch ports on your FortiGate, and even if don't, you can create virtual LANs. So let's create an interface. Let's just name our interface sales. The role of that interface is local area network. Just assign specific subnet to that interface. This is a private IP address. Use for management HTTPS and SSH. HTTPS to get to that interface through the GUI, and SSH is through the command line, and just configure a DHCP server. Now, you probably have only about 5 to 6 employees, so don't use the full pool. You can use, if in our case it's 10.0.9.2, so let's use it up until .10. Now, you can do many other things. We will not get into it right now, but this is the basics of just creating a new interface, and be sure to connect those employees through their computers to that specific switch on your FortiGate, either using a switch or directly. All right, now once you've built the interfaces, you can actually start to configure some rules. Let's just use basic rules for now. We head over to policy and objects, IPv4 policies, create new, and let's just create a sales policy. Now, we're not limiting no one in our sales department. So the incoming interface is sale, the outgoing interface is our WAN interface, the interface that is connected to our ISP router. As for source, currently we will use all, but we will create a firewall address object very soon, and we can actually use it in our firewall policies. In terms of service, we will allow any service, any protocol to go through this firewall policy. We will enable NAT. We will not use currently our security profiles. We will do it soon. And we will log just about every session, not only security events session. All right. So that's our sales policy. Let's create a new policy. Let's name it marketing. And incoming interface is our marketing. Outgoing is our WAN. Source all. Destination all. Service all. Let's just enable logging for all sessions. All right, the next thing to do is to actually create a virtual LAN for our access point. Now, there are times when you need to create another broadcast domain which is on top of physical ports. So if your FortiGate has 8 ports, you can actually create on top of each port VLANs, virtual LANs that you can connect to that switch, and from there to outsource employees or other employees. So let's just use the sales port to create another interface, which is our VLAN interface. Let's name it outsource 2, and we will use a tagging of 300. Let's also use it here. And the interface, as we said, is the sales interface. Now let's configure an IP address as we do in just about every subnet, every LAN that we have. So we'll use the 192.168.2.1/24, and we'll use administrative access, HTTPS and SSH, and we will actually list the full pool in our DHCP server. We will not limit it to only specific number of IP addresses. Okay, now once we have that VLAN on our sales interface, that's VLAN 300, we need to create a policy that will allow any traffic that is coming from that VLAN to get out to the internet. So we will again create a new policy. Let's name it outsource to. The incoming interface is our VLAN, is outsource to, and the outgoing is our WAN interface. Now, anyone can connect to that VLAN, anyone can go anywhere, but in terms of service, we will not allow any service out there. We will use HTTPS, HTTP, all right, and DNS. All right, now let's just apply that, and now we have a new policy that allows anyone that connects to it to get out to the internet only using HTTP, HTTPS, and DNS. All right, now let's create a firewall address object. Why do we need a firewall address object? Well, sometimes we have different computers on our subnet that we want to limit or to grant access to specific services, and that's a good way to create a policy that is more granular. So to create a firewall address object, we'll go to policy and objects, addresses. Now let's decide that our firewall address object will be for the marketing division. That's at the 10.0.5.0 subnet. And we know that we have a user that has the 10.0.5.3 IP address, and we want to limit it from sending pings, sending ICMP protocol pings. So how do we do that? We go to the policy and objects, addresses, create new address. Now let's name our computer limited ICMP. That's a nice name. Let's use the IP range, and let's use the 10.0.5.2 up to 10.0.5.2, or we said that it will be .3. And the interface is the marketing interface. Okay, we can also use static route configuration if we want to use it in a specific static route, but we don't need it for now. Let's just apply that. And now let's create a new policy. And in our new policy, we will name it no ICMP for that specific device. So the incoming interface is marketing, the outgoing is the WAN interface, and the source is the new limited ISP source that we have just created. Destination all, service ICMP. We want to limit it from sending ICMP ping. So we'll choose all ICMP and ping, and in the action we will choose deny. Okay, so now we have a policy that denies ICMP or denies pings from that specific users. Now for that policy to work, we need to actually move that policy before the marketing policy. So our firewall will look at that policy, will understand that that specific device, which belongs to the marketing division, doesn't have full access the same as the other user. It limits him from sending ICMP. Now the next thing you will need to do is to create a static route so that all packets from different interfaces will know where to go in order to get out to the internet. So to do so, you'll go to network static route, create new static route. Now I have already created one here. That's my static route. The destination is all zeros. That is, every packet that is destined anywhere and doesn't have a route in the routing table will go through that static route. You will need to choose the interface. In our case, that's the WAN interface, which is connected to our ISP router. We will not look at the administrative distance or the priority of that route, but know that you can actually prioritize different static routes on your FortiGate firewall. Alright, so we actually reached our final step, final configuration, which is applying security profiles to your policies. Now, you can find security profiles just beneath policy and objects, and you have different security profiles. Each security profile have its own knowledge base, and you can find dozens of videos in my channel that explains how to work with antivirus, web filter, DNS filter. The idea is that you actually create a security profile and then you apply it on your policy. So let's just open one policy, let's edit it, and here you can find the different security profiles. Once you enable it, it actually scans the traffic and looks for viruses, malware, spam, domains that are not permitted, and other things. Asymmetric encryption is being used just about everywhere. Let's look at the following scenario and then we will dive in and understand how it actually works. So let's assume that Eve wants to send a message to Bob. She writes down the message, she encrypts it using its own symmetric key, and then when it is all encrypted, it is being sent to Bob. Now, Bob knows the key. It knows the symmetric key that Eve used. He uses it, and by that, he actually decrypts the message. Now, if you think about it, we actually achieved only one thing. We encrypted the message. But then again, we have other challenges. The first one, how can we deliver the key between Eve and Bob? Let's assume that Eve and Bob doesn't live close by. The second challenge is, how can we tell that the message wasn't modified? How can we tell that no one actually modified with the bits of the message itself? And the third challenge, how can we tell that the person who claims to be Eve is really Eve? For that, we have asymmetric encryption coming up. When Eve encrypted her message, she actually used asymmetric encryption, and the key that was used by the algorithm was known also to Bob. Let's just take a look at the terminal and let's just make it bigger, and let's generate a random key. So we'll use for that OpenSSL rand, which is a command that allows you to generate pseudo-random numbers, integers. Let's use a key in hexadecimal, and let's use an 8-byte key, and that is the key. That is the key that could be used in asymmetric key encryption and that both parties should be aware of. So if we get back to Eve and Bob, Eve used this key with its algorithm. It could be either AES, it can be DES, it can be 3DES, any symmetric encryption algorithm. And Bob used the same key. So both parties has the same key. They both know that the algorithm is either AES or 3DES, and the message could be decrypted on the other side. On asymmetric encryption, Eve actually generates two keys, key pairs. They may look similar, but they are actually different, mathematically related, but different. The first key is the private key. The private key is actually the secret key that Eve needs to keep in a secret place. The second key is the public key, and as the name suggests, it is public. Everyone can use that key. Now, when Bob gets the key, it can use it for asymmetric encryption and actually decrypt messages that were sent by Eve. It can also encrypt his own messages using the public key. Just send it back towards Eve and Eve can decrypt it. So if we'll go back to OpenSSL, let's just write down OpenSSL, GNRSA. RSA is one of the algorithms of asymmetric encryption, and we'll use the 2048-bit key. And that's our private key. That's our private key. We can actually generate the public key from the private key that we have just generated. But that's the private key that Eve has actually generated, and as we said, it should be kept secret. And there we have it. Eve generates a private key and a public key and sends the public key again to Bob. Now Bob gets its public key, and from now on it can decrypt Eve's messages. Now think about it. The fact that only his public key can decrypt Eve's messages suggests that the message actually came from Eve. That's one way to authenticate the other side. Now, in fact, asymmetric encryption is not used to encrypt the session itself, the data, the payload that is being sent from Eve to Bob and vice versa, for many reasons. One of them is the size of the keys. So what actually is being done is that the private and the public keys are being used to encrypt the session keys, the symmetric encryption keys. They are much smaller in size and they are being decrypted and encrypted much faster than asymmetric encryption keys. So Eve can actually generate a pseudo-random key that is a symmetric key, encrypt it using its own private key. Bob can get the encrypted message, open it with its own public key, and now he knows what is the symmetric key that Eve will use to encrypt the whole session. Auditing your firewall is a major task that you need to do from time to time. Now, there are companies that release tools that will allow you to audit your firewall, but here is the 10 best practices that you can start with. The following best practices are not in a specific order, so just use them as you wish. Now, another thing, I'm showing it on a FortiGate firewall, but you can also do it on a Checkpoint firewall, on the Palo Alto firewall, any next generation firewall. Quite obvious, but we do it on any device, any servers that we have on our organization. Be sure that your firmware is up to date. Always use the latest firmware. Usually the latest firmwares are much more secure. Your firewall vendor will always make sure that you have the latest patches on the latest firmware. So back up your configuration, look at the release path, and update your firmware. Encryption and high encryption is fundamental in your firewall. So be sure that you always use the strongest algorithms. Now, it's not always possible, but assuming that the other side also supports the strongest algorithms, just find out the appropriate CLI command on your firewall and enable it. So in a FortiGate firewall, it is config system global. Now it may change from firmware to firmware. Set crypto strong and just be sure to enable it. Always make sure that your administrator is connecting to your FortiGate through a trusted host. That is a trusted IP address as the IP address at its home or in the office. Now, you can do it using the graphical user interface. You can do it using the CLI. Let's do it using the CLI, config system admin. Let's edit the admin. And from here, set trusted host. And just write down the trusted IP address. If possible, on your WAN interface, your external facing interface, don't allow any administrative management. So let's just use the config system interface, edit port 1, which is my internet facing interface, and unset allow access. On your LAN interface administrative access, try always to use HTTPS and SSH, that is HTTPS to the graphical user interface and SSH to the command line. Now try to avoid ping and try to avoid other protocols unless needed. The following is probably one of the first audits that you need to do. Look for unused rules, rules that were asked time ago and configured on your firewall. Look for them, and if they're not relevant anymore, just delete them. Now, a side note, document any rule that is asked. Document who asked the specific rule and the time that it was configured. Your administrator should always log into your FortiGate or any other firewall using HTTPS. So be sure that even if it tries to do it over HTTP, your firewall will redirect the request over HTTPS. So let's do it here. Config system global, set admin HTTPS redirect. Another setting that you should be aware of is the admin lockout and the admin lockout duration. Now, that should comply with your organization policy. Config system global. And now let's set the admin. You can set the admin lockout duration. The default is 60 seconds, but you can set it to 5 minutes or more. That should comply to your organization policy. Now, another setting is the threshold itself. That is, the lockout threshold is actually the number of failed attempts, when your admin tries to log into the system. The default is 3, and it is a best practice to keep it at 3. Logs should be part of your auditing. That is, when you audit a firewall, be sure that logs are there for at least 7 days. Now, look at the proper documentation of your firewall. Let's just do it here. Config log disk setting, set maximum age. Now, you can set it to 7 days. You can also set it to 30 days. It depends a lot where you save the logs, either on your hard disk or towards a syslog or any other device that has a proper storage. At last, let's look at some more best practices to hardening your firewall. One of them is when you have unused interfaces, disable them. If you have interfaces that you want to disable different protocol, so just disable them using config system interface, edit the interface that you want to disable, and there you can unset DHCP relay services, you can unset PPTP client, ARP forwarding, and so on. Another thing that is quite common to any FortiGate out there, and that is something that I'm not familiar with other firewalls which have maybe yes or no the same functionality, is what is known as the maintainer account. The maintainer account is actually a backdoor to your FortiGate. If your admin has lost its password, then it allows you to actually boot into your FortiGate using what is known as the maintainer account, which is actually the serial number of your FortiGate with the maintainer user. So you can actually disable it. In most FortiGates, I believe that it is enabled by default. Set admin maintainer account disabled. So you've got your new FortiGate. How do you configure it? Coming up. To get more easy setup tips for your FortiGate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. So you've got your new FortiGate and your new two FortiGate firewalls. What do you need to do? You have probably connected your FortiGate using a network cable to your computer and configured it. FortiGate appliances comes with at least port 1, one of the ports, which is usually port 1, that is already configured with the IP address of 192.168.199. You need to configure your PC subnet to be on that same subnet, get to the IP address of the interface, of the port 1 interface, and from there you're actually starting to configure your FortiGate. Now you can configure a FortiGate using the graphical user interface, which has many features. It even has a feature visibility feature in the system settings, so that you can disable or enable new features which are not available over here. Now you can configure your FortiGate using the graphical user interface, and you can configure it using the command line. FortiGate experts use the command line almost all of the time. We will look at the command line, but we will make our way using the graphical user interface. To get to the command line, you need to click here. It is actually a JavaScript app that runs on top the admin web app. Probably the first thing that you want to do is to write down get system status, so you can see your FortiGate serial number, which ASICs, which accelerated hardware does it support, are you using a hard disk or a flash drive, the current security profile database, and so on. Now we went into the interfaces. You probably have one interface that you're connected to, which will be the management interface. Now you need to connect one of your WAN interface to your ISP, either through a modem router, or you can use your FortiGate as the router itself. Each interface has a physical switchboard that you can connect to different subnets in your network. Now let's just edit one interface. Let's see what's inside. You can name your interface according to the subnet in your local area network. Let's assume that we have a management subnet. All right, now you can define it a specific role. It can be a WAN, a DMZ, an undefined role, or a WAN. So let's use the LAN. So now we know that we have a management LAN connected to port 8 on our FortiGate. Now, the addressing mode can be manual, it can be DHCP. Let's use the manual option. And let's configure it to be 192.168.2.1/24 since we're using a 24 subnet. Now, this address is the gateway interface address. So any computer that will connect to one of to port 8 will get an IP address in that subnet, that is the 192.168.2.0 subnet, but its gateway address will be 2.1. Now we will also open the DHCP server, so anyone that is connected, there's a pool of IP address that it will grab. We'll look at DHCP server very soon. Before that, we need to configure administrative access. Which protocol will support administrative access? We'll just use HTTPS and HTTP. For now, we can also use SSH. We can also configure it to support pings from host in that subnet or from a FortiManager, but we will not do it right now. LDP is a protocol that enables discovery between devices in the network. It doesn't really matter. You can disable or keep it for now. Now we have a DHCP server. As I said, any client that connects to that port will receive one of the IP addresses from the pool. You don't have to use all the pool. You can use only 20 IP addresses. You can keep the DNS server the same as configured here, or you can specify your own DNS server. Let's just specify Google's DNS server. You can control the list time, and if you click on the advanced, if you have a DHCP server that is part of your domain, which is not your FortiGate or your FortiGate interface, you can configure its IP address here, and then whenever a packet arrives on that interface, it will head over to the DHCP server. But for now, we're using the gateway interface as the DHCP server. You can configure an NTP server. You can configure, and this option is for more advanced users, DHCP scopes or options, and you can assign different IPs to different devices based on their MAC address. Another option is device detection. Device detections allows your FortiGate to detect which device and which operating system devices on the networks belongs to. This is one of the things that you should keep enabled. Don't bother with the explicit web proxy. You can enable a captive portal, so if you have outsourced employees and you wish to jump a landing page with user credentials, you can also do that, but we will skip it for now. So this is the basic configuration of the interface. Okay. So now we have a management interface. We have another interface, which is the WAN interface that you connected you connect it to your ISP router. We will call it WAN1. The role is WAN. We can use DHCP, and if we want to make it more reliable, we will use a static IP address. So my gateway interface is 10.0.3.75, and my router is actually 10.0.3.1. I've enabled HTTP and HTTPS, and as you can see, you don't have a DHCP server whenever the role of your interface is WAN. That is one of the best practices when using an interface as a WAN interface. Okay, so we have a management interface, we have a WAN interface. Now we want to make our managers that are connected to that port, which is port 8, to get out to the internet. So the next thing to do is to configure a policy. Now we will configure a very basic policy, which is a full access policy. Let's name it managers 1, and the incoming interface is management. That's the LAN interface of our managers. The outgoing interface is WAN1. That is the interface that is connected to our ISP router. That is the interface that takes them outside of the LAN towards the internet. Now when it comes to source, for this video, let's make it very generic. Anyone can go. Anyone. We can configure user groups and different users. We can also configure sets of parameters that control the different users. But for now, as for source, anyone can get out. As for destination, they can go just about anywhere. We can also create specific objects that will allow them to go to specific places, but for now they can go just about anywhere. As for scheduling, we're not limiting them to specific hours or days. So as for scheduling, again, they can get out to the internet any time of the day. As for service, we can deny them from getting out in specific services such as FTP, but for now, for our specific policy, we will let them use just about any service. Now the action is accept. We can also create a policy that will deny specific services or specific users from getting out or from doing specific things. For now, the action is accept. Inspection mode is another topic that we will look into. That is the inspection that is done to our networks when we're using security profiles such as antivirus or IPS. For now, we will keep it at flow-based mode. Now, we will use NAT. NAT is Network Address Translation. That is our private IP address, which can be 192.168.2.6, will be translated to your FortiGate or to your ISP public internet address. Now we will not use security profiles. You know what? Let's use antivirus. Let's use the default profile, the default antivirus profile. We will use certificate inspection. When we use certificate inspection, your FortiGate checks the different fields that are coming from server certificates to see if they're valid, if it doesn't have any mismatches, and so on. The last thing is to use our logging options. We can log only security events, but we will log all sessions. So later on we can look at the login report and see what our users or what our host did. Okay. So we have a managers one policy. We have two interfaces. The WAN one, which connects us to the outsides, and the management interface, which managers in our company can connect to and get their IP addresses. That was the second step. Now the third step is to configure a static route. A static route is actually, for our usage, will be a default route. That is, I've already configured one, so let's just look at it. If you want to create new, you just create new. So default route actually tells your FortiGate that whenever he sees a packet, any packet that is destined to any place which doesn't have a route at the routing table, it will route it towards the WAN interface. And the WAN interface address is a 10.0.3.1. Remember, my ISP router has that address. Now you can use specific parameters as distance. You can use priority. It just tells me that I already have that static route, which I do. And once we have a static route, a policy, and the interfaces that are configured correctly, we can now connect our host to the management interface, and those hosts can now get onto the internet. Let's just move to the CLI and let's see how do we configure interfaces using the CLI. So for the sake of our purpose, let's configure port 7. So using the CLI, we will use the config system interface. Now let's edit port 7 as we said. Let's set its IP to 192.168.4.1 with a subnet of 24. Let's set the management protocols to HTTP and HTTPS. And what else? We can use many more. If you will look at the, let's end it. Now I want to show you something. When you config system interface, let's just get out here. Config system interface, and if we look at port 1, for example, we can use the show full config, and as you can see, there are dozens of features of configurations that you can add. For our sake, we have only enabled the IP address on that interface, and let's look at it. Let's just refresh our page. Port 7, and there it is. Now we can also configure the DHCP server and so on. We have not done so on our CLI. The last thing I want to show you, once you get into your FortiGate, you're actually the FortiGate administrators. Now you have two types of administrators on, actually you have more than two types, but the two most common types is a super admin, which is you. You have privileges to just about anything. You can read and write, and you can create another type of administrator, which is the professional admin, where you can actually enable it, different read and write privileges on the different places on your FortiGate. If you will head over to the CLI and use the config system admin, and you can edit the admin name. I have two admins. I have one which is the super admin, and the second one which is offer test, which is my second admin. So now let's look at the different configurations that you can add to your admin. Again, lots of configuration. That's not the only place where you can configure different things. You can also configure it on a globally, which is the config system global. But one of the things that I wanted to show you is that you can strengthen your admin account by using a trusted host. So you can also look at it here. Here. You can configure a trusted host, that is a trusted IP address that only your admin can get from. So you can configure the IP address on your office at your work, and you can configure another trusted host, which is the IP address at your home. Only from those two IP addresses your admin can get into the FortiGate. You can also configure two-factor authentication, which is also a very common security procedure. You can use FortiToken, and you can also use your email as a two-factor authentication. Let's just show you how to do so. Let's clear that out. So we can use the config system admin set. No, let's edit the profile before and set two-factor email, set email to, and let's set it to one of my Gmail accounts. Let's end it, and now if we'll go back to our admin profile, let's view it again, and you can see that you can now use an email-based two-factor authentication. WebFilter is probably my favorite security profiles. It has so many features, either in a flow-based inspection mode, a proxy-based inspection mode, when using deep SSL inspection. One of the features that is supported only on proxy-based inspection mode is the restrict YouTube access to specific channels. Let's see how we do it. To put specific YouTube channel on a blacklist, you will need to get hold of the channel's unique ID. You can do it in several ways. One of them is to right-click with your mouse, view page source, Control F, channel ID, and just copy the channel ID that you wish to block. Let's copy it, and let's get back to our FortiGate. Now, the next thing, you can do it also on the graphical user interface, but let's do it over the command line. Let's config web filter profile. Let's name our profile block YT. That's the name of our security profile. Let's set YouTube channel status to blacklist. You can have either blacklist or whitelist, but we are blacklisting the channel so that any other traffic to other YouTube channel will pass, but this one will be blocked. The next thing to do is to configure YouTube channel filter, and let's edit the first one. Let's set the channel ID to the one that we have just copied, and let's just end. And now let's refresh our page, and we have a new security profile which actually puts our channel into a blacklist. Now you can only do it if you're using a proxy-based inspection mode and if you're using deep SSL inspection. So let's just create one, but before we create it, we also need to create an application control security profile that will monitor YouTube. So move over to your security profile, application control. Let's create another security profile, monitor YouTube, and let's create a new application, YouTube. Now let's just find all these signatures. We need this one, and that will be enough. Add selected. All right, now the action itself should be monitor and not blocked. Okay. So now in our policy, just use any policy that you need those security profiles. Be sure that the inspection mode is proxy based. Be sure that the inspection, the SSL inspection, is deep inspection. And on your web filter, choose the block YouTube channel, and on the application control, monitor YouTube. Your IPS sensors are critical to your network security, but how do you create a sensor that will not only block the connection, but will drop it, that is not sending any TCP flags that will allow the attacker to know that there is someone out there? And how do you configure the IPS sensor not only to drop the connection, but also to quarantine the attacker? We can do all that using our command line. Let's see how. Our command line will let us configure our IPS sensor with more advanced features. Let's just do it right now. Let's start with the config IPS sensor. Let's name it high. That is only high severity signatures. And now let's configure the different entries. And let's enter the first one with the severity level. That's the aim of our sensor. And let's make it only to high severity signatures. All right, now let's move to the second entry. And let me name it. All right, now let's set it to enable. And now let's set several things that are crucial to your sensor. The first one is the action. Now the action can be either pass, block, reset, or default. That is the default behavior of that signature. We will set it to block. When we set it to reset, your FortiGate actually sends back a TCP resets and lets everyone know that there is something out there. When we set it to block, it just drops the connection and doesn't send anything back. So a best practice is to set the action to block. Now, the other thing is to set the quarantine. You can set it to block the connection and quarantine the attacker. So you can set quarantine attacker, And you can set the different warranty expiration time and duration and so on. Let's leave it at the default expiration, which is 5 minutes, and let's just end it, and let's see how it looks in our IPS sensors page. Let's refresh the page, and we can see that we have a new sensor here with high severity level that also blocks the connection, that is the default action, and quarantines the attacker for 5 minutes. Now let's make our IPS sensor more descriptive. So let's use the config IPS sensor. Let's edit the sensor that we have just created. Now let's set the comment to block with no TCP reset, so that everyone that looks at that IPS sensor knows that it doesn't only deal with high severity signatures, but it also blocks the connections without sending the TCP reset flag. All right, that's it. Now let's refresh the page itself, and we can see that we have a comment which is the block with no TCP reset. When you configure a captive portal to one of your LAN interfaces, you can change and customize the look and feel of it. Coming up. So we have our LAN interface, which is connected to my Ubuntu device. So let's just open up the interface itself. And in network security mode, let's just choose captive portal, and let's choose a group that it is associated with it. Now you can choose your guest group, your outsourced employee group, just about any group you choose. All right, now when we head to our device, so let's enter Firefox, and that's what we get. We get the Fortinet logo, and the background is gray. Now we want to change it, so let's see how we do it. Let's just get back to our FortiGate. Now to do so, you need to go to System Replacement Messages. Now you have two views, the simple view and the extended view. We'll use the simple view, authentication, login page, edit. Here you will see the image itself and the HTML part. Now we will not get into the different texts that are in the login page. You can change it, but let's see how we change the image from Fortinet to FortiTip. Alright, so to do so, we'll head over to Manage Images. Let's create new image. Let's name it FortiTip. And let's upload the image that we have already prepared. You need to have an image which is less than 24 kilobytes. Alright, so that's the image. That's the name of the image. Let's name it FortiTip1, since I already have a FortiTip image. All right, so here is FortiTip1 and FortiTip. Now let's get back to our login page. Let's edit. Let's just scroll the HTML page, and let's find the logo part. Here's the logo part. Currently it is with a background, a gray background, so let's change it to all Fs, that is white in hexadecimal values. And let's just change the image to FortiTip1. There we have it. Now let's just save it. And now we have a new login page, a new HTML page with our new image. So let's get back to our Ubuntu device. So let's start Firefox again. And there it is, the new logo, FortiTip logo. And again, you can change the background as I did. You can change the different text that is within the login page. You can do many things with the login page. One of the rather newest features of your FortiGate is the Content Disarm, that is CDR. Content Disarm is available under the antivirus security profile. It only works on a proxy-based mode, and what it does is actually stripping content from Office files and PDF files. Coming up. Alright, so we have dozens or hundreds of files that are sent every day over the email, which is the #1 virus and malware attack surface. And sometimes you want to block that content up until it is being scanned by a Forti sandbox. So if we configure our content disarm and reconstruction, we can choose either to discard the embedded content or send it to a Forti sandbox if you have one. Now, one thing to note is that doing so, you can actually choose which content to disarm and which not. So you head over to your config antivirus profile. That is after you have set up a profile with a CDR enabled. Now let's edit one of those profiles. I have a profile which is block ACAR. Okay. And now you can use the config content disarm, and if you will show the full configuration, you will see that you can set to enable or disable content disarm on specific files and specific formats. That is, you can enable it on macros and disable it on hyperlinks in a PDF. So use CDR, use it as it is one of the best tools to protect yourself from zero-day viruses. That's all for now. If you like videos like that, please subscribe. Your FortiGate certificate private key is crucial if you need to copy that certificate to another Fortinet product in your organization. How do you do it? Coming up. Whenever you need to generate a certificate for your FortiGate for any reason, either SSL VPN or to authenticate an administrator with a two-factor authentication, you will need to generate a CSR, a certificate signing request. Now, once you do so, your FortiGate actually generates two keys. The first one is the private key, which should be held secretly on your FortiGate. This key will be used to decrypt and encrypt sessions from different users that are connected to your FortiGate. The second key is the public key. That public key is actually embedded along with the certificate itself, and clients will use it to connect securely to the FortiGate itself. Now, how do you generate a CSR? So you head over to your system, certificates, generate, name your certificates. Let's name it test cert, enter your IP. I will use my private IP, but you will use your public IP or your FQDN. Organization unit, organization name itself, let's just name it FortiTip. Locality, city, I will use Tel Aviv. Country region, let's use Israel. Email, I will use FortiGateGuru@gmail.com. Now, this one is mandatory. You should choose a password to create the private key using the RSA algorithm. Now, don't be tempted to use the 4096-bit. It is more secure, but it does influence performance. So the default setting is RSA 2048-bit. Let's just create our password and use file-based enrollment. Now, once you do so, you will see your certificate in the certificate page. It is in a pending mode up until your certificate will be issued by a CA. You should download this CSR file, attach it to your CA as part of the CSR itself. Once you get the certificate, download it to your computer, import it, and now you will see it as part of the certificates in the certificates page. But if you need to import that certificate to another Fortinet device, you will need two things. You will need the private key and the certificate itself. You can do so by using the command line config VPN certificate local. Now edit the name of the certificate that you have just received and use the show full, sorry for that, use the show full config. Once you do so, you will see the private key, which you will need to copy. You will need to copy the private key, paste it on another file, name it private.pem, and grab the certificate itself, paste it, and name it certificate.pem. Those two files are needed to import your certificate to another Fortinet device. There are times when you need to back up your configuration and send it via email to another compliant FortiGate. Now, there is one thing that you need to add up to your backup configuration file. Coming up. So there's our use case. We have another FortiGate and we want to send it our primary FortiGate configuration. Now, the other FortiGate must be compliant, but we will not get into it. So let's look at the configuration file. That's the configuration file. Let's just open it. And there it is. Now, we don't want no one to tamper with our configuration file, to get into the file itself and change things. How do we do it? We make a checksum. We make a hash value of the configuration file and add up the hash value to our mail. So to do so, I'm using a Mac terminal, but you can use PowerShell. You can use just about any tool with the hash commands available. So in my case, it is SHA-SUM-A. Now, we need to choose the type of hash function. I'm using 256, but you can also use 1. In our case, it doesn't really matter. Now, let's just drag the file to our terminal, and there we have it. That's the hash value. That's the hash value of our configuration file. So the next thing to do is to copy it, open our email, and just be sure to add up the hash value of our configuration file. Now, the other side that gets the configuration file itself just grabs the file, makes the same operation, which is SHA-256 sum and the file path. It should get the same hash value. If it doesn't get the same hash value, then someone tampered with that file. There are different ways that you can prioritize your cloud apps over the other apps. One way is to use a traffic shaping policy. Here's how. The following scenario is quite typical for many businesses. Now, if you're using more than one WAN interface, you can use static route, create different static route to each WAN interface, and prioritize different internet services. You can also prioritize the interfaces. You can even use SD-WAN rules and performance SLA. Now, we will look at a case where we have only one WAN interface, and we will do it using the traffic shaping policy. So the very first thing that you will need to do is to move over to your policy and make sure that application control is on. The second thing you'll do is to move to security profile, application signatures, and there we will create an application group for the cloud applications that we used most often. So let's just name it Cloud Apps. And from here we can actually use the category, which can be Cloud IT, or we can actually select our applications. So let's use the AWS, which we used often. Let's add up Salesforce. All right. And let's add up Office 365. There we have it. Now, let's just save our application group. We can see that we have a new application group that includes all of our cloud apps that our workers use most often. The third thing that you will need to do is to create a traffic shaping policy. Now, if you move to the traffic shaping policy under policy and objects, you will see that you have two main traffic shapers. One is the high priority and the second one is the low priority. Both are in the shared IP shaper. So let's move to traffic shaping policy. Let's create a new traffic shaping policy. Let's just name our traffic shaping policy Cloud Apps. The source can be all, destination all, service all, in application. Now here is the place where we actually use our application group. So just look for the cloud apps that we have just created. That's our application group. And here in the shaper we will actually apply, let's just add up the WAN interface, and here we will apply the high priority shaper. We will apply it in both shared shaper and reverse shaper, so that we'll have also the downlink and the uplink with high priority. Okay, so we have a policy, we have a traffic shaping policy for cloud apps. So let's create another traffic shaping policy for any other apps. All right, again, source all, destination all, service all. Now you can choose the applications, but you don't have to. And here in the traffic shaping place, let's just use the low priority, both in the shared shaper and in the reverse shaper. And now we actually have two traffic shaping policy. If you enable application control on your policy, your application control sensor will actually notice whenever you use Salesforce or other cloud apps, and your traffic shaping policy will actually prioritize it over the other. Your FortiGate firewall is a session-aware firewall. It has its own session table, which can be seen using the get system session list. And there are cases when you need to tear down a specific session or the entire sessions that are on your FortiGate. How do you do it? Coming up. Your FortiGate is a session-aware firewall. It holds information on its session table and keeps looking at its session table every time a packet goes out through a different interface or gets into another interface. Your session table actually holds much more than this session itself. It holds the routes, that is, whenever your FortiGate does a route lookup, it saves the information in the session table. Now let's look at our session, get system session list, and we can see that we have dozens of sessions, some of them to the same destination. I currently have a Ubuntu device which is at the 10.0.5.4, and let's assume that I need to clear out all session. So the command for that is diagnostics session clear. Don't do that. Don't do that. It's quite dangerous to clear out all sessions that are happening on your FortiGate. Instead, we will use the filter option. Now you can filter out different sessions either by source interface, destination interface, source, and even protocol, which is quite interesting. Now we will use the source. So let's use the source, which is the 10.0.5.4. And the next thing to do just after that is the diagnostics session clear. Once you do so, just press the enter, and specific sessions, the sessions that you have filtered, will be terminated. Your FortiGate uses its memory for the different processes, either IPS, antivirus, or general functionality. Now, when it reaches your memory threshold, it gets into what is known as a conserve mode. How do you control it, and how do you decide which operations takes place when you enter conserve mode? Coming up. Getting into a conserve mode is not a desirable thing. Now, there are actually 3 thresholds that you can actually configure by yourself, and those thresholds determine when you enter a conserve mode, when you exit from a conserve mode, and when the sessions are being dropped as you're entering an extreme threshold. So let's take a look at it. Let's just stop our Diag system and let's config system global. And in config system global, you can actually set the different thresholds. Now, the extreme threshold is actually the threshold or the percentage of total memory when your FortiGate starts to drop session. You can also set the green thresholds, which is the thresholds where your FortiGate exits from the conserve mode. And there's the red threshold, that is the thresholds when your FortiGate enters conserve mode. Now, when your FortiGate enters conserve mode, something happens. The first one, your FortiGate doesn't accept any configuration changes. The second thing, it doesn't execute any quarantines. Now, there are other things that you can configure as sessions on your IPS engines and antivirus. So let's just get out of the different thresholds. Config IPS global. Set fail open. Now you can decide either to enable fail open or disable. If you enable IPS fail open, packets will still flow, will still go through the different interfaces, but with no IPS inspection. If you choose to disable it, the packets that require IPS inspection will be dropped. Now, if you want to check if you're in the conserve mode or not, you can just use the diag hardware sysinfo conserve. If you do so, you can see that you're currently not in a conserve mode. If you were in conserve mode, you would see the on instead of the off. And you can also see your total RAM and the memory that is being used. You can also see that the threshold for the red extreme mode is actually 95% of total RAM. You will enter conserve mode at 88% of total memory, and you will exit from conserve mode when you get down the threshold of 82%. The ability to block specific content, that is words, phrases, patterns, on web pages is one of the most valuable features in Web Filter. Let's see how we do it. To get more easy setup tips for your FortiGate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. Alright, so before we start and configure our banned words filter, we have to remember two things. The first one is that each word that is detected has its own score. By default, the score is 10. The second thing is that your filter has a threshold, a specific threshold. Currently, it is by default also 10. That is that if you find only one word that has a score of 10, your FortiGate will block it. But if your filter has a threshold of 30 and it finds only one word or two words that has a score of 10, it will not block it since they did not reach the filter threshold. So when you configure, give specific words different scores. So you might have the word 48 that you want to ban for some reason, a score of 30. And in that way, if your filter has a threshold of 20, it will ban the page even if it only finds the specific word. So let's create a new profile. Let's name it restricted words. Now we will use regular expression. Let's head over to static URL filter, content filter, create new. You can create patterns using wildcard or regular expression. Let's use regular expression. Let's use two words, Fortinet and FortiGate. Let's close the parenthesis. Let's enable it, and okay, now we have our profile. The second thing is to apply it to our policy, but before that, let's move to our Ubuntu device. Let's just see. Let's just move to YouTube. All right. And that's my channel. Now, my channel has the word Fortinet and FortiGate in it, and currently it appears with no issues. Let's move back. Let's add up the security profile restricted words. Okay. Now, before we move back to our Ubuntu, let's move to our filter using the CLI. Config web filter profile. Let's add it our restricted words profile. See the full configuration, and you can see that currently the threshold, the banned word threshold is 10, so it will probably block my channel. Let's move back to Ubuntu, show Windows. Let's close Mozilla since sometimes it holds a cache of that channel or that page, and move back to youtube.com /FortiTip. Now let's see what happens. And yes, it blocked that channel. The page you requested has been blocked because it contains a banned word. How do you control data consumption and bandwidth when everyone is at home? Coming up. To take control over data in COVID-19 times, we can use the traffic shaping policy in our FortiGate. So let's move to policy in the objects, traffic shaper, create new shaper. Now we can use a shared shaper or we can use pair IP shaper. So let's use pair IP shaper. Let's name it COVID-19 streamer. So we'll know that it is for our streamer device. Now the maximum bandwidth, we will limit it to 30 megabits. And let's save our shaper. The second thing to do is traffic shaping policy. Let's move to traffic shaping policy, name our policy COVID-19. Now the source, we will need to create an address object for our streamer, so let's just do it. Let's streamer 1, since I already have one, 10.4.10.0.4.9/32. Okay, so we have our streamer device as our source. Destination is all. Now we can use specific applications such as Netflix and so on, but we do not want to limit our streamer device only to streaming applications. We want to limit the traffic as all. So we will not use the application or the URL category, but we will use in outgoing interface the WAN interface, and now we'll use the pair IP shaper. Select your traffic shaper that you have just configured, and that's about it. Hundreds of files are entering your network every day. How do you create an IPS signature based on CRC, cyclic redundancy check? Coming up. Whenever you use a file-based signature that is based on cyclic redundancy check, your FortiGate actually uses a register with XOR mathematics to look at the file binary digits and produce a signature which includes its checksum and its file length. Now, CRC is usually used for error detection, but in our case, it is used as any other hash value to recognize specific files. Alright, so let's log in and let's create our signature. To create our signature, we need to head over to our IPS signature. Now we can create new signature. Let's name it block CRC, and we always start our signature using the FS bid. Then we open our parenthesis, and then we use our keyword and our value. Now we use double dash and the name of our signature. Fortinet will create from our signature an attack ID. So let's name it block CRC. And let's continue. Our protocol is TCP. And our CRC32. Now we need to add up the CRC value and the file length. For that, I will use my terminal, my Mac terminal. So let's move over to my terminal. Let's choose a file that we want to block. Let's assume that this file is to be blocked. So we start our command with cksum. Alright, now let's add up the file itself, the file path. Now we have the file path. Let's just enter and we get our checksum plus the file length. Let's just look at that a bit bigger. So we add up our checksum and now let's add up the file length. So that's it. That's actually the signature to block a specific file that has a specific checksum value. The same way as our antivirus database looks for hash signatures of different files to look for viruses. Now once we finish with the signature, we can always find it using our IPS signature in the custom IPS signature. So you have your database of pre-configured IPS signatures and you have your own custom IPS signature which you can add up to your policy. Crypto mining malware or cryptojacking is a form of a malware that actually uses your own resources to mine cryptocurrencies. Now, the attack vectors, the way that the crypto miners gets into your organization can be either from botnets, it can be from malwares, it can be from JavaScripts that runs on your browsers. Now, as we've seen in the last several years, it can run on your routers, it can run on your PCs, on your Android smartphones, or on your servers. How do you protect your organization from crypto mining malwares? Coming up. Crypto mining software comes in many forms and can actually get into your resources from different locations. So how do you block them? Well, there's no one recipe. You will need to apply different security profiles. The first thing to do is to apply the antivirus security profiles in your policy. Why? Because Fortinet has actually included different signatures for crypto mining software. So if you're using either the normal database or the extreme database, just apply them to your policy. The second thing is to block different crypto botnets, and there are dozens of crypto botnets out there. So be sure to block botnets on your botnet package. The third thing to do is to block different applications that are related to cryptocurrency. How do you know which applications to block? Well, you can head over to the FortiGate Labs and just look for cryptocurrency. There you will find different applications that actually tries to mine different cryptocurrencies. So the thing to do is to open your application control and in the application override, just find the different signatures and block them. The other thing, as we said, there are different JavaScripts that run on your browser and you will also need to block them using your IPS signature. Which signature is that? So again, move to your FortiGate Labs, look for the different cryptocurrencies signatures, but if you want to be just a little bit more precise, look for javascript.cryptocurrency. And there you will find different generic JavaScripts that can run on your browser and you need to block them. So just copy this one and block it on your IPS engine. Let's look at the following scenario and configure it quickly. So you have a specific server on your DMZ that needs to go out to another server that is outside your organization in a specific port number using the TCP protocol. So you need to create a custom service. The other thing is that it only needs to do so on specific hours in the night. So how do we configure a custom service? Coming up. A custom service is actually a firewall object that you can create and then use in your policy. To create one, you need to go to Policy and Objects, Services, and create new service. We will do it using the command line, but take a look. Each service is categorized into specific categories such as web access, file access, and email. So let's move to our command line. Let's use the config firewall service custom. Now let's name our new service. Let's name it backup. Alright. Now a new entry was added. So the next thing is to choose the protocol. So we're using TCP. So we'll use the TCP, UDP, and SCTP. Now we have said that the destination port is 52630. So let's set the TCP port range to 52630. And the other thing to do is to set the category. We have different categories. We will use the web access category. And the last thing to do is to set the IP range that is specific to that service. So in our case, let's just use an imaginary IP address range, which is 111 to 1112. Alright, so now we have the new service. We have named it backup. So let's go back to our services, web access. Let's look at the new service. There's the new service. Now, as we can see, the service is named backup. The range is 52630. We are using the TCP protocol. We are using a specific IP range. And now, if we will want to use that specific service in our policy, so let's name our policy. Let's name it DMZ backup. So the incoming interface is our DMZ interface. The outgoing interface is our WAN interface. Now, the two most specific things that we need to add to our policy is one thing, it is the new scheduling time. Let's do it a recurring scheduling object, which will happen on Monday, Tuesday, and Wednesday. Now, it's not happening all day. We have set it will only work on nighttime. So let's configure the time. All right, and let's name it backup. So we're using a new schedule object, which is the backup. And our new service is the backup service that we have just created under the web access category. It will work on the specific port range that we have configured, and it will be available for a specific IP address range the same way as we have configured. So let's use it. And now let's set up the source. We have not configured the source, so we will do it right now. Let's add a new address. Let's name our address NAS backup. So we have said that it will work on IP range that is 111 to 1112. All right. Interface, let's use the DMZ interface and be sure to enable the show in address list so we can see it in our policy. Alright, so that's the new source. As to destination, we haven't configured a specific destination, so it will be a good practice to configure it, but for now we will use all. On the following scenario, I will use the author microcontroller after connecting to it through the pwned SSID, and the authenticate, send the authenticate, and the associate frames towards an access point. Now, do it on your own risk. Do it only on equipment that you're allowed to do so, probably your own equipment. This demo is for educational purposes only. Alright, so to connect to the author page, we will head to the pwned SSID. Just type 192.168.4.1, and here we have several sections. The first one is the scan section, where the author actually scans the air for either access point or stations. Now we will select the access point, our access point that my TV, my other devices are connected to. Just select it and move over to the attacks section. Now there are several attacks. We will use the auth attack, and let's start the attack. But before we do it, let's just open up Wireshark and let's capture the air so we can see what is actually happening. So let's start the attack, and let's move back to our Wireshark, and as you can see, we have tons of the associate and the authenticate frames that are actually being sent. So let's stop the attack itself, and let's select the, let's just open the frame itself. Let's open the frame itself. Let's look for the associate frame, and we can see that it is being sent to the broadcast domains. So every station that will try to connect to our Wi-Fi access point or wireless router will actually get a de-authenticate frame and a de-associate if it is already connected to. When you want to get around your system admin, you can use the decoy technique in Nmap to scan the subnet that you're connected to, or the gateway that you're connected to. So we have our Ubuntu device, which is connected to the 10.0.4.1 subnet, and its IP address, let's just check it out. Let's use the ifconfig. The IP address of our Ubuntu device is the 10.0.4.8. So let's use the decoy technique and let's see how that looks in Wireshark. Alright, so the first thing to do is to open Wireshark. Let's capture traffic, and now let's move back to our Ubuntu device. Alright, and for that we will need root privileges, so we'll use the sudo. Let's use the full SYN scan, which is SS, and the target is our gateway, which is the 10.0.4.1. I remind you that's the gateway that our Ubuntu device is connected to. And the other thing to do is to use the decoy technique with the hyphen uppercase D. And let's presume that we are coming from the 10.0.7.33. All right. Now we get our results. We can see that we have HTTPS open. Now let's look at Wireshark. Let's close our capture. And let's use the IP ADDR equal 10.0.7. Let me just take a look. .33. And there it is. Although our IP address was 10.0.4.8, that was the Ubuntu address, we used the decoy technique in Nmap to pretend to be the 10.0.7.33 and get information on our gateway. Now let's use the same one to get information on our WAN interface. And now let's use the 32. Let's just open Wireshark again. And here we have it. We can see that our gateway is actually quite open in terms of ports. Just about any port is open here. So that's definitely a vulnerability issue. But let's just open up Wireshark and let's stop our capture. And this time it is 32. So there we have it. Our Ubuntu device is trying to connect, is actually connecting to our WAN port. And to the right, we can see that our client is actually sending a SYN packet without sending back the acknowledgement. So you browse the internet and everything seems just okay. Let's just head over to cnn.com, see what's new. It uploads well. Let's go to bbc.com. And yep, everything seems okay. So, but now you decide that you want to ping somewhere just to check that there's no connectivity issues. And it seems that you do not have a DNS result. So let's stop that and let's try to ping directly to Google's DNS server. And yet again, you have an issue with ICMP. So how do you get around with that? And how do you diagnose the issue behind it? So let's get back to our FortiGate. Let's log in. And probably one of the first things that I would have done is to diagnose sniffer packet any host. Let's just write down the IP address of our host and let's just see what happens. All right, let's just make that bigger. And it seems, let's stop that. And it seems that I have an echo request, but I'm not getting any echo response back. Only echo requests. So that's not enough. And it seems that packet capturing my traffic doesn't give me the solution to my problem. So the next thing to do is to work at the kernel level, and that is using the diag debug flow. So let's just get back to our main command line. Let's clear the space here and let's diag debug enable diag debug filter. Now let's filter, sorry, diag debug flow filter. Let's filter our source, which is the 10.0.4.9, and let's diag debug sorry for that. Diag debug flow, trace, start. So what I'm actually doing here is that I'm debugging the source address 10.0.4.9. I'm doing a trace only on the first 10 packets. So let's see now what happens. And let's just stop that and see if I have any clue that will resolve my issue. And yes, there it is. Denied by forward policy check, policy number 2. So I actually have a policy that denies ICMP. Let's get back to my FortiGate. Let's look at my policies, and that's right, I have a policy which is stop ICMP from my DMZ, where my Ubuntu device sits, towards my WAN interface. Now this exercise is good, since sometimes we have dozens of policies that we do not have time to check. Maybe they're unused policies from some time ago. So Diag debug flow will work on the kernel level and will allow you to debug issues just like this one that I showed you now. 2-minute CLI commands, and this time the Diag Sniffer coming up. Diag Sniffer packet is one of my favorite commands. Why? Because it actually allows you to packet capture the traffic, sniff the traffic just as TCP dump or Wireshark does. So the syntax goes like that: Diag Sniffer packet, and then you need to include the interface. So we will do any, but you can choose port 1 or port 2. After that, you actually filter the traffic. You can filter it using the source destination protocol. We'll use the host, so we'll use the host 10.0.3.1, which is my gateway. Next comes the verbosity, that is the amount of data that you want to include. I will choose 4. And we can also add up the count, that is the packet count. So let's add up 10 packets. And if you want a timestamp, you can add the A letter. So let's start. And there we have it. Now you can play around with the different filters and the different verbosity levels. Do that. If you want a packet capture, not using the Diag Sniffer, but using the graphical user interface, you can do it in network, packet capture, and in packet capture you will find that you can choose the interface and use the different filters. If you're using one of FortiGate's latest firmware, then you will find out that the DLP, the data leak prevention, is not there anymore, at least not as a graphical user interface. Now, parts of it went to the web filter. You can actually use the file filter and block different types of files. But credit card and social security numbers, blocking or logging, can only be done using the command line. So let's take a look at how we configure a credit card sensor using the command line. Coming up. Credit card sensor matches numbers from credit cards. Those can be from MasterCard, Visa, American Express, and so on. Now, it can be used with files or with messages, that is, email messages. So let's configure our first credit card sensor, and let's start by config DLP sensor let's just edit. Let's create an entry and config filter, and our first filter will be number 1. All right, so let's, you know what, let's skip the name of the filter. Let's set the type to message. We can also use files, but we are actually using now messages. And let's set the protocol. Now, since we're aiming at email protocols, those will be SMTP, POP3, and IMAP. All right. Now let's set the filter by credit card. You can also use social security number, or you can actually use regular expression if you're looking for specific patterns in the text itself, but we are using a credit card sensor. Let's just, now let's use next, let's end it, and let's set DLP log to enable. And that's it. That's how you create a basic credit card sensor. Now, there are other options that you can choose from, such as sensitivity and so on. So I urge you, look at the CLI reference and configure it the way you want. Let's look at some specific DNS settings that will make a change in your network coming up. You can configure your system DNS settings under the network DNS, where you can specify your DNS server's IP address. You can even set it up to work over TLS, which is a topic that I covered before. But let's look at the command line, and let's look at two configurations that are important. So let's config system DNS. Now here you can set up the primary DNS server or the secondary DNS server. Let's just set the primary to be Google's DNS server. And two configurations that are important are the cache time to live and the cache size. So let's set the set DNS cache limit, that is the amount of records that can be saved on your cache. By default, it is 5,000, but you can set it up to a much higher number. That depends on your needs, but I have found that 5,000 records are quite enough. The other configuration that you need to look for is the set DNS time to leave. Now, the time to leave is the amount of time that the DNS record is saved in your cache. That is the DNS response that you've got back. Now, it is being saved on your cache. It actually serves you faster since it comes from the cache. It is much faster. It doesn't need to go all the way to an authoritative server. The default is 1800 seconds, which is 30 seconds. The maximum is about 86,000 seconds, which is 1 day. Now, 30 minutes, as we said, is the default, but let's set it up to 1 hour, 3,600 seconds, and let's end it. And now let's just refresh our page, and there we have that our primary DNS server is the Google's DNS server. The secondary is actually FortiGuard servers. Now, one thing to note, if you for any reason need to clear your DNS cache, you can do it quickly using the Diag test application DNS proxy. Now look at, once you press the enter button, you will see that you have different options. So just use number 1 and you will clear your DNS cache. By nature, your DNS queries are unsecure. They are being sent over UDP in port 53, And anyone who gets hold of your gateway, either the ISP or anyone else in a coffee shop, can look at the queries and change them. We call that a man in the middle. Now, over the last 3 to 4 years, we have heard of DNSSEC, DNS over HTTPS, and DNS over TLS, which is now available on your FortiGate. How do we configure it? Coming up. DNS over TLS and DNS over HTTPS are two standards. Android, starting from version 9, supports DNS over TLS. More and more vendors are starting to support DNS over TLS, and your FortiGate also supports it. Now, the difference is that in DNS over HTTPS, the DNS queries are being sent over port 443 along with other encrypted traffic. In DNS over TLS, it is being sent over the TCP port 853. So let's take a look at how a UDP port 53 DNS query goes along in Wireshark, and let's see how it works over TLS. So let's just open up Wireshark. And let's execute ping towards google.com. Alright, so we have our ping, and let's just stop our capture. udp.port equals 53. Sorry for that. 53, and there we have the standard query, the different queries towards our destination, which is Google. Now let's just go back, and now let's enable DNS over TLS, and we have actually two options. The first one is enable, the second one is enforce. You can see that we are using a certificate, since TLS is actually SSL. So when we use enforce, we are actually using this strict mode, which goes only through TCP port 853. If we will use the enable mode, if we will not find a resolver that supports DNS over TLS, we will go back to UDP port 53. So let's use the enable, and let's apply that, and let's just start to capture with our Wireshark. Okay. Now let's execute ping towards akamai.com. And we have our ping being sent, and everything looks okay. Now let's stop our Wireshark capture. Now let's use UDP. No, sorry. Let's use TCP.port equal 853, and we can see that we actually have a TCP query being sent towards FortiGuard DNS servers. Let's create a denial of service policy and see how that looks in Wireshark. To get more easy setup tips for your FortiGate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. In the following scenario, we will use a denial of service policy. We will try to create a denial of service attack towards our gateway interface, and we will capture it using Wireshark. So we have one of our interfaces, which is the marketing interface, at the 10.0.4.0 subnet. The gateway interface itself is 10.0.4.1, and our DHCP client, which is the Ubuntu device, is at 10.0.4.9. So let's move to our Ubuntu device. All right. Let's just clear that. Let's try to ping our gateway 10.0.4.1. Everything goes well. The rate is very slow using the casual ping command. So let's stop that. And now let's create our denial of service policy, and then we will use the -f using our pseudo credentials to create a flood of ICMPs. Alright, so policy and objects, denial of service policy, create new policy. We are protecting our marketing subnet. Let's use for source, we can use specific devices, but let's use source and destination all, service all. And now let's move over to layer 4 anomalies. ICMP flood, there it is. Enable it, block it, and let's set the threshold to 20 ICMP packets per second. So what we will see once we do it and try to ping our gateway interface is that only 20 packets will get a response back, and the other ones not. So let's move to our Ubuntu device. Before that, let's just start capturing user. Sorry for that. Capture using Wireshark. All right. Let's move. Now, using the pseudo credentials with the ping command and the -f, the -f, which is a flood, we are sending hundreds of ICMP packets towards our destination. So let's just ping it. As you can see, it runs very fast. Let's wait a while and let's stop it. Now you can see that only 20 packets, that's the threshold, only 20 packets were received. The other 96 packets were lost due to our denial of service policy. Now let's move to Wireshark. Let's stop the capture. Now let's apply the filter ip.addr equals 10.0.4.9 and ICMP. We can see that we have a request and a reply for the first 20 packets. Following that, we only have echo requests that were sent from our Ubuntu device, but they are not acknowledged and we don't have a response. Moving back to our FortiGate, we can head to log and report and look for anomaly, and there we can see the record for our ICMP flood attack, for our denial of service attack, and we can see that we have an anomaly which is an ICMP flood with a threshold of 20 packets only. Using two-factor authentication is a common security procedure. Usually we do it using tokens, but for this video we will look at doing so using our own email address. Let's start. To get more easy setup tips for your FortiGate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. For the purpose of our demonstration, we will use my second admin account, which is OfferTest. It is a professional admin account. Now, if I'll try to edit it using the GUI, we will see that in the two-factor authentication, we only have two possibilities. The first one is FortiToken and the second one is FortiToken Cloud. To get our third option, which is the email, we should head over to our command line, config system admin. Now you will edit the profile that you wish to add the email two-factor authentication. In my case, it's OfferTest. You will set the two-factor email, which enables you to have the third option on the GUI itself, and you can set the email to where to send the token itself. Let's set it to orangehello@gmail.com. Okay, so let's end it. Now if we will refresh the page, we will see that we have a third option. Okay, now the next thing to do is to go to System Settings, set up your custom or default email service. I've left that using the Fortinet SMTP server, and let's just apply that. And now let me just log in using my account again, and there I have it. I am asked to input my token code. Let's move to my, there it is. Let's just copy it. And I am in. One of the new features that was added to Web Filter is the file filter. File filtering was in earlier version part of the DLP security profile, but now it was added to the web filter. And so let's create a new web filter. Let's block the file format PDF. We can do it with multiple file formats. The protocols that we will scan for is HTTP and FTP. And now let's look for PDF. Let's add it to our file filter. The action is block. And now the next thing is to add it up to our policy. So let's take our already configured policy. Let's enable the web filter, block PDF, and apply. Let's move on to our Ubuntu device and check it out to see if that really works. Let's try to download a PDF file. Let's find files. Let's look for NTFS file. And there it is. We have our web filter blocking our attempt to access the NTFS PDF file. So you have your LAN set up, your WAN interface set up, you have your static route and your policy. Now it's time to fine-tune your security profiles. Coming up. The following is not a recipe or a cookbook, it's all about fine-tuning tips for your security profiles. So let's start with the antivirus. Now you can configure your antivirus settings using the command line. Let's just get out of what is already on the screen. Config antivirus settings. And from here you can choose, let's just show the full config, you can choose the different databases that you wish to work with. So set default database and you can move between normal, extended and extreme. Be sure to also set the grayware to enable. Grayware are actually apps that are not by definition viruses or malwares, but these are apps that can harm and decrease your performance, such as adwares. The second thing is web filter. Starting from 6.2 or 6.23, you can now block different file types. So you can block zip files, you can block PDF files, you can block exe files, you can block them on different protocols. So be sure to do so. Another thing about web filtering is that you have proxy options. Be sure to enable proxy inspection mode on your policy. On DNS filter, you can block different botnets, but the thing about DNS filter is that you're actually blocking a domain. You're not blocking a URL. So you cannot block a subset of a domain, which is a URL, but you can block the full IP address or the full domain. So this one will work much faster on your FortiGate than web filtering. So be sure to be aware of that. In application control, you can actually block, override, enable different applications based on their categories. You can also block a category and override a specific application that belongs to that category. You can do it here, application and filter override. You can, and it is a best practice to block quick as Google's new protocol, since it actually influences your FortiGate performance and capabilities. Moving on to intrusion prevention, be sure to use IPS, create different and customized signatures if you need, but the most important thing to do is to configure your signatures based on the filtering options. If you're targeting clients, be sure to use the client filter. If you're targeting servers, if you're targeting different severity levels or different protocols, be sure to customize your IPS signatures based on the topology on your organization. Now, this is only the tip of the iceberg. There are lots of other configurations that you can do, such as config antivirus heuristic. You can use your web filtering with deep SSL inspection to log just about any keywords that your employees are looking for. You can use application control to enforce protocols on specific ports, and so on and so on. You can create customized signatures for specific events or specific anomalies that you're looking for. You can create a denial of service policy that is based on different anomalies, but be sure that it will be productive for your purposes. So we have seen that a firewall rule actually matches traffic. It matches traffic that flows between the firewall different interfaces. And if it finds a match, we have seen the different criteria. Those were the incoming interface, the outgoing interface, the destination, the service scheduling, and so on. Then it does something, either to allow the traffic or to deny it. And now we will look at what happens next. Now, a good analogy is when you head over to an airport. Now, the first thing that you, or the first person that you meet is the security person that asks you so many questions. Where did you come from? Where are you heading? What is your destination? Did anyone brought you something to deliver? And so on and so on. That's the first step of a firewall rule. The next thing it does is sending you to a baggage check. Now, what happens at a baggage check? Well, they check your baggage. They check the payload itself. Although everything seems okay and the traffic is getting approved and is destined towards its destination, no one really knows what you're hiding in that traffic. And that is the baggage check, and that is exactly what a security profile does. So moving on to security profiles, if we click the security profile menu, you will see that you have different security profiles that you can enable on your traffic. Now, once you create or use one of the default profiles, you can move to your policy and enable it on the traffic flow. You have a section that is called security profiles where you can actually enable or disable, and as you can see, once you click on it, you will see that you have different profiles to choose from. So here I have on my web filter profile, I have about a dozen different profiles that are enabled on my traffic. You do so since the profile needs to be custom made. It needs to be custom made to your network needs, your network topology, your network baseline. Don't just use any security profiles. If you enable antivirus, you may use different databases. You may choose that you want to use a heuristic scan. So don't just use any security profile out there. Use them carefully. Use them in a custom made to your needs. Let's move over again. So we have an antivirus, we have web filter where you can actually monitor, block, allow different URLs, different categories, enable safe search. You can log even search keywords from your users. You have a DNS filter where you can also block different domains, even block accessing a botnet sites. Application control using a layer 7 view on the different applications that you're using, either remote access, peer-to-peer, voice over IP, proxy applications, and so on. You will see that in just about any security profile you have also the option to override specific applications or specific URLs, even if you block different categories. You can block applications that are detected that they're not using their default ports, such as port 21 for FTP or any other known application ports. Intrusion prevention is probably one of the most known engines, and that's one of the reasons that your FortiGate is a next generation firewall. It scans for two main things. It scans for exploits, that is vulnerabilities, and it also scans for anomalies. You can actually configure different sensors based on the target, either servers or clients, based on severity, based on the protocols, and based on the vendors and the vendors' applications. One of the known policies that you can use within your FortiGate is a denial of service policy, which relies heavily on your IPS engine. And here you can actually configure thresholds for different layer 3 and layer 4 traffic. That is protecting yourself from a SYN float, an ICMP float, or even from scanning your ports using tools such as Nmap or Nemesis. There are so many things that can be said on security profiles. I will only mention two other things that I will not get into in this video, but you can see my channels. I believe that I have several videos on that topic. The first one is the inspection mode. Your FortiGate supports two inspection modes. The first one is flow-based mode. The second one is a proxy-based mode. They make a difference when you choose one on the other. And the second thing is the inspection, is the certificates that you actually use different certificate options when scanning the traffic. You can use the basic certificate inspection, which will check only the different fields, validity of a certificate and so on. And you can also choose deep inspection that will allow your FortiGate to inspect encrypted traffic. You can actually check your encrypted traffic and see if it has viruses, malwares, intrusions, and so on. Firewall rules are basically the bread and butter of every firewall out there. It doesn't really matter if your firewall is a next generation firewall. Whenever you head out to the internet and you're using a firewall, then you're obliged to firewall rules. What are firewall rules and how are they made? Coming up. To get more easy setup tips for your FortiGate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. A firewall rule is nothing more than a set of criteria that your traffic needs to match. Whenever an IP session happens in your network, a set of rules are being matched against that traffic. If your firewall doesn't find a match at the first rule, then it goes to the next rule. Rules are handled from top to bottom. Now let's look at how a policy rule is being configured and what objects are used to create that match. In every rule, there's always the implicit deny rule that sits beneath every other rules. That is, if your firewall doesn't find any match in the traffic, then the traffic goes to the implicit deny rule and it is being dropped. So when we start to configure our firewall rule, we have, as we said, an implicit deny rule at the bottom. And from there, we start to configure our different criteria that will be matched against your traffic. Now we start with the name of the rule itself. As for naming conventions, don't use too many characters. Don't use spaces between words. Try to use underscores. The second thing is the incoming interface. What is the incoming interface? Well, that's the interface that your local area network is connected to, your DMZ is connected to, whatever interface that the traffic is coming from. The second criteria is the outgoing interface. So that usually in a full access rule, full access policy, that is your WAN interface. When you configure your rule to allow traffic from the LAN towards the WAN and the internet, but it can also be another segment of your enterprise, another LAN. It can be the DMZ. The incoming interface is known as the ingress interface. The outgoing interface is known as the egress interface. So we have two interfaces, the incoming interface, the outgoing interface, and from there we move to the source. What is the source that makes the traffic? Well, that can be your clients. That can be just about any source, that is any IP address, or you can use what is known as firewall objects as specific IP addresses within your local area network. It can also be a user or a user group that is saved on your firewall internal database or a remote authentication server such as LDAP or a Radius server. Another criteria is the destination. What is the destination that your traffic is heading towards? It can be any destination, that is any IP address out there. It can be a specific IP that you can configure, or it can be a domain, or maybe an internet service, an Amazon service. So be sure to be granular. Don't just use any or all. Be specific. If you're configuring a full access policy that will allow anyone to get out towards the internet, then it will probably be all. If you're configuring specific destination, then be sure that to configure them ahead and use them in your rule. The next thing is scheduling. Do you want your policy to work out 24/7? Or do you want it to work on specific hours, specific days, reoccurring days? So you will probably have cases where you will be asked to open a firewall rule for a specific appliances in your local area network. It could be a backup device, it could be a network attached storage. Be sure to know what times are those appliances need that firewall rule. The next thing is service. Service, that is, which protocols are being used in your firewall rule. Are you using only HTTP, HTTPS, and DNS, that is port 80, port 443, port 53, or are you allowing your employees to get out to just about anywhere using any protocol out there, including FTP, SSH, and so on? So again, be careful with the service usage rights. And the last thing is the action. Are you denying or are you allowing traffic based on that match? Now, this was actually only the part one of your policy or rule creation. The next thing, once you have a match, is to go through security profiles. That is going through antivirus, application control, IPS, and so on. The other thing that you will have to take care is, are you using network address translation? Are you logging all sessions or only security events? If you look at my channel, you will find dozens of videos related to security profiles and other features of your firewall. So please check out, subscribe, and see you soon. Fortinet has given us decent tools to look at our logs, analyze them. Some of us are just using the log and report. Some of us are using FortiAnalyzer, but there's another way, which is not as sophisticated as FortiGate logs. But let's see how we do it using the built-in tool in just about any Linux distribution the grep tool. Let's start. To get more easy setup tips for your FortiGate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. So what we're doing right now is actually using the basic tools for data analytics. There are many tools that you can use in Linux. I'm currently using the Mac terminal. So let's move over to log and report, web filter. Let's download the log file. Let's see how it looks in the Finder. And let's name it disk.log. So if we will move towards the terminal, let's just open it using cat command. Sorry, cat. All right. So you can see that you have tons of information. Now, let's use grep. Let's use grep. Now, let's look for two similar patterns. The first one will be the time, and the second one will be the level severity. We want those two to be on the same line. So let's do it. Grep 08 50 minutes, that's the time. Now we'll pipe it into another grep command. Let's just mention the file, which is disk.log. Now let's pipe it using another grep command. Now let's make a boundary for the second word. Let's just name it warning and not warnings or any other. Let's add the character B as a boundary, and let's look at what we have. No, let's add another thing. Let's add the color option, which is hyphen hyphen or dash dash color equals always. Named it GERP, not grep. And there we have it. We can see the warning level, which appeared at 8 and 50 minutes. And we were also looking for, no, those are the only two. Let's add the color to the second word. So we will also have it. All right, so here we have from the full web filter log, we only looked for an event in the warning severity level, which happened at 8 and 50 minutes. The following scenario is as follows. You have your local LAN users, you have your access point that is broadcasting its signal in the air, and you have an outsourced employee that starts to work at your organization, and you want to create a guest user. How do you do it? Coming up. Creating a guest access involves several steps. Now remember, a guest access is mostly an account that has a limited time period. So let's start with a user group. Let's create a new group. Let's name it guests. And the type will be guest. Now from here it's quite self-explanatory. The user ID of the guest will be its email. Now you can use an auto-generated password that your FortiGate will generate, but let's use specify, and when we will create a new user account you will see where to enter it. Now you can add up sponsor, you can add up company, and the period, let's add 24-hour period. So our account period will be 1 day. Now the next thing to do is guest management, where we create our user account. Remember, our user ID is the user email address. Now let's add up the password. Let's add the email itself. The company will be FortiTip, and let's just make sure that the expiration time is 1 day. The other thing that you need to do is to create an administrator that will handle the guest account. Let's name it admin guest, and let's add up its password, a simple password. Now the profile will be professional, and just choose the restrict admin to guest account provisioning only, and the guest group is the guest that we have just created. Now if we log out, let's just enter again as our admin guest. Let's see what the admin guest sees when he enters your FortiGate. Well, that's the thing that he sees. Well, that's what he sees. He sees the different accounts. He can add up new account. He can delete accounts. So let's log out and let's enter again. Okay. The last thing to do is to add up a captive portal to the interface where your outsourced employees will connect through. That's our interface. Security mode, captive portal, and restricted to the guest group. Okay, so now we have user group, we have created the user account, we have chosen the password, but the password can be auto-generated and sent to our user email. And now let's move over to our Ubuntu device, which is connected to our interface. And from here we have the captive portal. And there we have it. A valid model within just about any networking vendor out there is to add up a second device for reasons of backing up your network or making it a more reliable one. Within FortiGate, it is known as HA, High Availability. Let's see how we configure our FortiGate to be a member in a cluster. To understand how HA works, we will look at the following topology. So we have an internal network which is connected to a switch, and that switch is connected to our primary FortiGate, which takes us out to the internet. To create a cluster, to create an HA, we need to add up another FortiGate. That FortiGate has to be the same model, has to have the same licenses. You can look at the Fortinet documentations and see the requirements. The two FortiGates are connected through a link which is called a heartbeat. That heartbeat link is responsible for the synchronization of the two FortiGate. It is responsible to elect the primary FortiGate. It has lots of tasks, but we will not look at the specifics of it. You need to understand that you need to have at least one heartbeat link. The second thing is the monitored ports. You have to connect your secondary FortiGate to a port on the main switch. Now, when you create a cluster, you actually create a group. You have to name that cluster, and you have to assign it a mode, either active, that is the two FortiGates will be responsible for the different sessions on your network, or active, passive. In that case, only the primary FortiGate takes care of the different sessions, and the second one is actually passive. It is listening to the primary, and whenever there is a device or a link failover, it takes its place. Now let's look at our FortiGate and see how do we configure our FortiGate to become a primary FortiGate. Alright, so let's log in. Now, you can configure your HA using system HA. You can choose either modes, active, or active, passive. You can also see using the get system status that currently your FortiGate is in a standalone mode. That is, it is not participating in any cluster. When you look at the configuration itself, you can see that you have to assign a shared secret, a password, between the two FortiGate. Now let's move over to the command line and let's configure our primary FortiGate using the CLI. We will use the config system HA. Now the first thing that you will do is to assign a group ID. Let's just create a group ID. Let's create a group name. Let's name it cluster 1. And now let's set the priority. Now the higher number, that is from 0 to 255, the more chances that your FortiGate will be chosen to be the primary FortiGate. So let's make our FortiGate, let's configure it with the number 150, and on the secondary FortiGate just choose a lower number. The other thing to do is to set the mode, either standalone, active, or active, passive. So let's choose the active, passive. Now let's choose the monitored ports, which are the ports that are connected to the switch. The other thing to choose is the password between the two FortiGate. So let's use 1, 2, 3, 4, 5, 6. And the last thing to do is to configure the heartbeat ports. These ports are keeping the cluster communicating with each other. It actually sends packets between the two, keeping synchronization the same between the two FortiGates. They are also responsible for the election of the primary FortiGate. Now you will see using the show full config that you have many more configuration options that you can add up to your system HA, such as the interval in the heartbeat interfaces and so on. But this is the basic configuration that will set you up and create your FortiGate a primary one.